Good morning, everyone. My name is Deepika. I'm from Computer Science and Engineering Department, IOD. Today, I'm going to brief you about the fundamentals of cryptography. In that, particularly, I'm going to talk about the topic block cipher design principles. So first, let us go into the slide. First is a block cipher design principles. In that, block ciphers are built in Feistel cipher structure. Block cipher has a specific number of rounds and keys for generating ciphertext. Block ciphers is a type of encryption algorithm that process fixed size of blocks of data, usually 64 to 128 bit to produce ciphertext. The design of block cipher involves several important principles to ensure the efficiency of algorithm. It's nothing but like in a block cipher, normally the ciphertext is a process of converting a plain text into ciphertext. It depends upon the plain text. Okay, in this we used to transfer the plain text to ciphertext in the form of blocks. So each and every so in this feature structure we have taken. In feature structure normally we have 64 to 128 bits. So we used to transfer 64 bits as a block and then we used to transfer it. In this we have some property principles in this. First is design of function, confusion and diffusion, key size, key schedule, block size, non-integrity, avalanche effect, and security analysis. So next coming to the point, it's okay. Next is a number of rounds. So what do you mean by number of rounds? The number of rounds is the iterations, how many iterations it follows during the every encryption to the ciphertext. It means the plain text is converted into a ciphertext. So with this 64-bit and 128-bit, how many rounds it takes to make us a ciphertext? Okay, so design of function is nothing but like the function performed in that. First, this 64-bit is divided into two sessions, so 32 and 32, left 32 and right 32. So from this right 32 a function is being performed. For this performing a function, a key is used. Okay, so the key is normally of a 32-bit. From 32-bit a function operation is used, and with an avalanche effect then it is been converted to 56 bit key, and again it is converted to 48, and it is infused in the operation of function. So confusion and diffusion also comes under that. In that, a cipher should provide confusion and diffusion. It is between the plain text and ciphertext. The confusion and diffusion that also occupy inside this. The key size. So the key size, what is a key size? The key size should be a large enough to prevent brute force attacks. The large key size means that there are more possible keys, making it harder for an hacker and guess is correct. So key size na, how many key size? Yeah, as actually I said before performing the function, simultaneously a key size is also generating side by side with a 32-bit or 128 bits. In that it is converted into 46-bit, and then it is then coming to the key schedule. The key schedule should be designed carefully to ensure that the keys are used to encryption depending upon the plain text. Okay, so depending upon the properties the key schedule is being scheduled. And the block size, yeah, already I've said like the plain text is divided into blocks so that it is being generated to the next operation. Okay, so non-linearity is nothing but an s box. So s box is used in the cipher should be non-linear, provide confusion. Avalanche effect is normally the cipher should exhibit the avalanche effect, which means small change in the plain text or a key causes significant change in the ciphertext. Only a minute changes in the plain text makes a significant change in the ciphertext. Okay, so security analysis is nothing but the cipher should be analyzed for the security against various attacks such as differential cryptanalysis, linear cryptanalysis, so and so on. So let us first go let us know the difference between the block cipher and stream cipher, because there is a difference between a block and cipher. The plain text is being converted to a block cipher to stream cipher. Okay, in the way of block cipher and stream cipher. So in the block cipher, it can be used only 64 bits, whereas in by the stream it can be used 88 bits. It is complexity of block cipher is simple, whereas the block cipher conversion is simple as compared to a stream cipher. And next is the block cipher uses conversion as well as diffusion, whereas in this stream cipher uses only the conversion. The block cipher is a reverse encrypted text, while the ciphertext is a, this is a basic difference. Okay, so this is we have to know the difference. And the key length is typically of 128 or to 256 bits, whereas the key length is typically 128 or 256 bits. The operation on a fixed length blocks of data, so it keeps on like it keeps on this stream cipher and block cipher is a type of converting the plain text into the ciphertext in the form of block and stream. So this is just the conversion of bits. The block is used for 64-bit conversion and the stream is used for 256 or 128 bits of conversion. This mainly uses in the algorithm to convert the plain text to ciphertext. Still I have more sessions. The next section will be continued in the next video. Please, thank you for your listening. Thank you.